Okay, time for our 16th, I believe. Here we go. We got to do some more about Venn diagrams. So no matter what I said before, we got Venn diagrams and set operations here. I mean, to solve problems, I meant to say. Sorry, solve problems. Okay, problem number one, which will just have two sets. Similar to a problem that I did in a previous video, one video ago or two videos ago. Here's the story. 40 states have casinos. That's what I got. That's the problem here. Let's take this problem. Cool. They have casino, and 40 states have some form of casino gambling. Okay, sorry about that. Now, 44. Lottery tickets. I just put lottery. Forget about tickets. Lottery. 36 states have both. That means both casinos and lottery. Okay. Now, we need to do a Venn diagram, obviously. We need to find out how many states. Here's the questions. There's a few questions. How many have only casino? Only casino. How many have only lottery? And finally, how many have neither? Those are the three questions, A, B, and C. Okay, and we want to use a Venn diagram. Let's move this up. Can't move it up too far. We got to see that information. I need that information still there. There it is. And we can still have, we have enough room for a Venn diagram. Now, here's the universal set. The universal set is all the states. That means there are 50 of them. But we all know that piece of information. So there's now on the left-hand side, let me put the casinos. And on the right-hand side, let's put the lottery. Okay, what belongs in all the sectors? Well, what belongs in the middle is 36 have both. So that's always start with the middle. That's the best way to go. As far as casinos concerned alone, it's going to be 40 minus 36. And that's going to be, there's going to be 4 in having casinos alone. Because that's minus the 36 that have both. Right? If they have both, it's not part of the casino alone. And the lottery is going to be 44 minus 36, which is going to be a total of 8 lottery alone. Now, what about the ones that have neither, that are outside casino and lottery? None of this. Well, there's 50 states, right? So 4 and 36 is 40. That's 48. 4 plus 36 plus 8 is equal to 48. And 50 minus 48 is equal to 2. And therefore, that's our complete Venn diagram. 2 belong outside all of the balloons and inside the universal set. Okay, so that is solving a problem, and there's only 2 sets involved. Let's go to a little bit of a harder problem when there are 3 sets involved. New piece of paper, and let's try this one. This is a longer story, not too long, but it's a little bit long on the long side. Okay, problem number 2. Here's the information. Okay, so someone makes a study, finds there's 300 people jailed, 300 inmates, and it's a criminal justice major, he's studying, etc. This is the problem I have here, which is will work for our purposes to explain. And this is when he's studying all this, and he finds that 194 are there for theft. Okay, but they could be arrested for something else too. 210 drugs. 170 for violence. Let's call it, it's assault, but let me just write that it's violence, and that makes it easier. Okay, no, but there's more information. That's 170. He also finds out that 142 are there for both theft and drugs. Theft and drugs. Okay, that's 142. 111 are there for drugs and violence. Drugs and violence. Okay, that's 111. 91 for theft and violence. Okay, and 45 for all three. Okay. Now, we need a Venn diagram, and a relatively big one. Okay, so I'm going to make it pretty big. There we go. And I'm going to put theft in the upper left. Okay, T for theft. Then D for drugs. And then V for violence. Okay. All right, so now here's the questions. I can put the questions here on the bottom, right? That's all the info. This is the info. All of this is the info. And the questions are, A, how many been arrested for only drugs? B, how many for theft and violence, but not drugs? No drugs. C, theft or drugs? Theft or drugs? And D, which I guess I'll put over here, D is none. None of these. Okay, so there's a total of 300 on all. And here's the most central thing. 45 is going to help us a lot. 45 for all three. Okay, now how can 45 help us? Here's the story. If we figured out 45 for all three, right? We know the 45 is all three. We have that information. So now let's go to the 142 that were for both theft and drugs, right? So here's theft and drugs. 142 for theft and drugs, but 142 is got to be minus 45, right? Because there's 142 for theft and drugs minus these, but these 45 are for all three. They have to be subtracted out. What's 142 minus 45? It's 97, belongs here. The same thing, what about, do we have some information about drugs and violence? 111 for drugs and violence, right? Drugs and violence is over here. So, but we've got to subtract out from the 111 minus 45. We do 111 minus 45, and we get 66. That belongs over here. Do we have some information on theft and violence? We do. 91. Theft and violence is between these two, but the 45 has to be subtracted out. So we do 91 minus 45, and we get 46. Okay, now what else do we need to know? We need to know how many people are in theft alone. Okay, so for theft alone, what do we have for theft? 194, but we got to subtract these all out. All this has to come out. So 97, 45, and 46. 46 and 47 is going to be 91 and 97. 91 and 97 is 180, 188. Okay, so what's 194 minus 188? This is all 188. So 194 minus 188 is equal to 6 for theft alone. All right, what about drugs alone? Drugs alone says 210, but we got to subtract out from the drugs. We subtract out all of this stuff from the drugs. Okay, 45 and 66 is 111. 111 and 97 is 208, I believe. So if we've got a total of 210 minus 208, there's only 2 for drugs alone. And now let's go for the violence. What do we have for violence? 170. So now we got to subtract out from the 170 all these three. 46 and 45 is 91. 91 and 66 is 97 is 157. How much is 170 minus 157? 13 for violence alone. Now, does this equal to 300? Does all this equal to 300? Count all these up, and you'll see that it's not equal to 300. So what is it all together? It's going to turn out to be a total of 275 when you count it out, and therefore 25 will be left outside all the boxes. Let's answer all our questions. Only drugs. The answer is, look it up over here, it's 2. Theft and violence, no drugs. Theft and violence and no drugs. Let's see. Theft and violence right over here, but no intersection with the drugs, so it's 46. Theft or drugs. Well, anybody doing theft or drugs will take all of that. So that's a lot of people. Theft or drugs is going to be 6 and 46. 6 and 46. I'm sorry, 46 and 45. That's 91. 91 and 97 is going to be 188. 188 and 6 is 194. 194 and another 68 is going to be 202 and 260. It should be 262. I can double check that. I just don't want to run out of time. As far as none is concerned, is going to be 25. Okay, so what do we have? Well, let me double check this last one, theft or drugs. Theft or drugs, you count all of this. Well, theft is going to be 194. Oh, this is 194. 194 and another 68. Let's do that again. 194 and 68. 194 and 8 is 202. 202 and 6 is 268. That's correct. 202 and and 60 is 262. All of these are correct. 2, 46. Answers are 2, 46, 262, and 25. How to get that 25 again? I'll tell you how. Add up all these, which is on 194. Add up the next 60. Add another 68 to it, and add another 13 to it. And what do you get? You get 4 and 8, that's 12, and 3 is 5. 12 and 3 is 5, carry the 1, 10, 17, and carry the 1. 1 and 1 is 2, 275. 300 minus 275 is equal to 25. That's how I got this 25. Okay, we ran out of time, but we finished the problem, and that's one of those more complicated problems with 3.